So now that we've learned molar mass and we've learned how to convert from grams to moles and moles to grams, we're now going to use that skill in stoichiometry. Stoichiometry allows you to start with a mass of substance A and go all the way to the mass of substance B. So the way that we do this is you have to communicate in moles. So the whole purpose of moles is that 1 mole of substance A would be equivalent to 1 mole of substance B. So if you are given something in grams, you're going to use the molar mass to convert to moles. And then you're going to use the mole to mole ratio in a balanced equation to convert to moles of the second substance or substance B. And then you can convert from moles of substance B into grams of substance B. So let's look at an example. So when magnesium hydroxide exists as a liquid, it's often called milk of magnesia because its milk-like appearance. Magnesium hydroxide can be used to neutralize stomach acid, hydrochloric acid. Okay. When those two react, they form water and magnesium chloride. So I've given you this formula. I've given it to you balanced. So 1 magnesium hydroxide plus 2 hydrochloric acids goes to 2 waters and 1 magnesium chloride. And now what we're going to look at is how to calculate the mass of magnesium hydroxide required to neutralize 5 grams of stomach acid. So you want to know the grams of magnesium hydroxide and you know the grams of hydrochloric acid. So the first thing you're going to do is find the molar mass of the hydrochloric acid and the magnesium hydroxide. So I've done this for you, right? So hydrochloric acid is 1 hydrogen and 1 chloride. And then the molar mass of magnesium hydroxide is 1 magnesium, 2 oxygens, and 2 hydrogens. So then you can see using this formula above or the template at the top, I've taken the grams of substance A, which is the grams of hydrochloric acid, multiplied it by its molar mass. So 1 mole of hydrochloric acid is 36.458 grams, so that I've converted from grams into moles. Then you're going to use the mole to mole ratio to go from moles of hydrochloric acid to moles of magnesium hydroxide. So we know that 2 moles of hydrochloric acid from the balanced formula produce 1 mole of magnesium hydroxide. Now I'm in magnesium hydroxide. So I've converted from moles of hydrochloric acid into moles of magnesium hydroxide. And now I'm going to convert from moles into grams of magnesium hydroxide. So I put 1 mole is equivalent to 58.326 grams of magnesium hydroxide. And then I just plug this into my calculator. So it'd be 5 divided by 36.458 divided by 2 times 58.326. And to 3 significant figures, because that's what my question gave me, I would get 4.00 grams of magnesium hydroxide is needed to neutralize the 5 grams of hydrochloric acid. So now what we're going to do is use that work that I've already done for you twice. We're going to use the milk of magnesium reaction again to calculate the mass of magnesium chloride produced when 25 grams of hydrochloric acid reacts completely. So we're going to use this same formula, but now what we're going to change is that they're giving you 25 grams of hydrochloric acid, and they want to know how much magnesium chloride would be produced. Now, whether you remember to do your molar mass first or last, it doesn't really matter, but we do have the molar mass of the hydrochloric acid, but we will need the molar mass of the magnesium chloride. So the magnesium chloride would be 1 magnesium and 2 chlorides. And we can see above that 1 magnesium is 24.31 grams. And then the 2 chlorines are each 35.45. So then the molar mass of the magnesium chloride would be, oh, where did I put my calculator? 24.31 plus 2 times 35.45, which is going to give you 95.21 grams per mole of magnesium chloride. Okay, so then we're going to start with 25 grams of hydrochloric acid. And we're going to convert that grams to moles. So 1 mole of hydrochloric acid weighs 36.458. I like to put my units in first for dimensional analysis, but sometimes they get in the way. Okay, that's now put me in moles of hydrochloric acid. I now want to convert from moles of hydrochloric acid into moles of magnesium chloride. And if I look at my coefficients on my formula, 2 moles of hydrochloric acid produce 1 mole of magnesium chloride. And now I'm in moles of magnesium chloride and I want to convert it to grams of magnesium chloride. So I know that 1 mole of magnesium chloride weighs 95.21 grams. So then in my calculator, I'm typing 25 divided by 36.458 divided by 2, because remember I can ignore all the ones, times the 35.21. And that will give me, to 3 sig figs, 32.6 grams of the magnesium chloride. Awesome. Okay, so maybe you weren't quite ready to pause the video yet, but maybe you are now. So for this last question, you're going to use the same reaction and you're going to calculate the mass of hydrochloric acid that must have reacted to produce 15 grams of water. So this time we're starting again. And this time I know that 15 grams of water was produced, and I want to know how many grams of hydrochloric acid that would require. So let's set this up. First thing we need to know is the molar mass of water. Water is 2 hydrogens and 1 oxygen. Each hydrogen is, 1.008, I believe. I think so. Yeah. And then 1 oxygen weighs 16. So then the molar mass of water is going to be 18.016 grams per mole of water. Okay, then we get to start the formula. This time we're starting with 15 grams of water, and I want to convert into moles of water. I know that 1 mole of water weighs 18.016 grams. Now I want to convert from moles of water into moles of hydrochloric acid. So I go up to my formula and I see that 2 moles of water comes from 2 moles of hydrochloric acid. So I'm going to put a 2 and a 2. And lastly, I want to convert from moles of hydrochloric acid, which would be 1 mole. And how much does it weigh? Well, we decide that hydrochloric acid is 36.458 grams. So then we're going to plug this into our calculator. We're going to go 15 divided by 18.016. And then you have a choice. You can times 2 and divide by 2, or you could just leave it, right? 2 divided by 2 is 1. So if you're nervous, go times 2 divided by 2, or just skip that step. And then we're going to multiply by 36.458. And to 3 sig figs, we would get a mass of 30.4 grams of hydrochloric acid must have reacted. Awesome.